All right, simplifying multiple radicals. Yesterday, it was just one number that you had to break down. Now, I'm getting a lot of people giving me answers as a decimal answer. That's how you estimate a radical. That's not how you simplify it. To simplify a radical, you have to leave the square root symbol in the problem still. You can't turn it into a decimal. All right. Today we're going to have more than one number that's inside of a square root. So I gave you the square root of 9 and the square root of 4 here, four different problems. One of them adding, subtracting, multiplying, and dividing. Now when it comes to square roots, you can't add or subtract them if it's not the same number inside of the square root. So I picked two numbers that are perfect squares, the square root of 9 and the square root of 4. So the square root of 9 is actually 3 and the square root of 4 is 2. So if you take the square root of those two numbers, you get 3 plus 2, and 3 plus 2 equals 5. The square root of 13 is not 5. The square root of 25 is 5. All right, so I picked these numbers on purpose so that it's a little easier to illustrate that they're not equal. 3 plus 2 does not equal the square root of 13. Same with the subtraction problem. 3 minus 2 is equal to 1, and the square root of 13 is not 1. So that's just one example, but it shows that it doesn't work. All right, now multiplying and division, that does work. If you take square root of 9 times the square root of 4, you get 3 times 2, which is 6, and the square root of 36 is 6. If you take 9 times 4, you get 36. So you can multiply radicals together. All right, same with division. If you divide, this one's a little messier, but 9 divided by 4 is actually, well, you would take the square roots first. Sorry. So the square root of 9 divided by the square root of 4 is 3 divided by 2, and 3 divided by 2 is 1.5. You could write it as a fraction 3 over 2 or 1.5. And that is equal to, when you have a division problem, you rewrite it as a fraction and you can simplify that fraction. Square root of 9 over square root of 4 is 3 over 2. And then you're right back to here, 3 over 2 or 1.5. If you were to divide these first, right, just like you could do when you multiply, you could say 9 times 4 is 36 and take the square root of that number. You can divide 9 divided by 4 and get 2.25. 4 goes into 9 2.25 times, and the square root of 2.25 is 1.5. So it still works that way. It's a little bit messier if you divide first and you don't get a whole number. It's usually pretty difficult to take the square root of decimals. But 2.25, if you move the decimal over, it's 225, and the square root of 225 is a perfect square. The square root of 225 is 15. So this is just a matter of moving decimals. So you can kind of see that it works, but basically you don't want to divide first. You don't want to turn 9 divided by 4 into 2.25. You just want to take the square root of the top and the square root of the bottom, get your whole numbers, and then reduce your fraction if it reduces. All right, another way that I try and explain this is why you can't add and subtract is think of variables. Think of like 2x and 3y. Say if you had 2x and 3y, you can't add those together and say that's 5xy. Those aren't like terms. They don't add together. Same with subtract. But you can multiply them. You can multiply that together and say this is 6xy. So you could kind of think of a radical as a variable, or at least it has the same rules as a variable. You can't add or subtract them together unless they're like terms. So if you had square root of 3 plus the square root of 3, now that'd be like x plus x, and x plus x is equal to 2x. So square root of 3 plus square root of 3 is equal to 2 square root 3. So you can add them if they're the exact same number, because then they're like terms. But if they're not the exact same number, you can't add them, just like with your variables. So that's another way that I try and explain this topic. So hopefully between those two explanations, it'll make sense that you can't add or subtract unless it's the same number. but you can always multiply and divide. And multiplying and dividing is what the work for today is all about. There's not going to be any adding or subtracting in there. It's all multiplying or dividing.